Lord, you seem so far away, a million miles or more it feels today. And though I haven't lost my faith, I must confess right now that it's hard for me to pray. But I don't know what to say, and I don't know where to start. But as you give the grace, with all that's in my heart, I will sing, yes, I will pray. Even in my darkest hour, through the sorrow and the pain, I will sing, I will pray. Lift my hands to honor you, because your word is true. I will sing.
Hello learners, you are welcome to today's lesson. In our previous lesson, we learned about how to organize data in a frequency distribution. So let's use one example to refresh our minds on what we learned the other day. Using the intervals 0 to 9, 10 to 19 to draw a frequency distribution for the data below. So this is the data that we are going to use in organizing our frequency distribution. We learned that in drawing our frequency distribution, we need our frequency table. So we draw our frequency table, and the intervals given was 0 to 9, 9 to 19. Then we go. But we consider the largest number in the data given, and in our case, the largest number is 49. So our intervals should be up to 49. That is why our interval is up to 40 to 49. Now let's make the tally for the distribution. The first number, which is 31, will occur in the class boundary 30 to 39. We have 40, which will occur in 40 to 49, so we make our tally. 20 will be at 20 to 29, so we make our tally. 35 will be at 30 to 39, so we make our tally there. 21 will correspond to 20 to 29, so we make our tally. 12 will have 10 to 19, so we go to that column and then we make our tally. 11 will be at 0 to 9, so we make our tally there. 39 will be at 30 to 39, and we make our tally there. 16 will be at 10 to 11, we go there and then we make our tally. 0 will occur at 0 to 9, and we make our tally there. The next value is 28, and it will occur at 20 to 29, we make our tally. Then 49 will be at 40 to 49, so we make our stroke. 29 will be at 20 to 29 class boundary, so we make our stroke there. 32 will be at 30 to 39, so we make our stroke there. 17 will come to 10 to 19, so we have our stroke. And then 2 will be in the interval of 0 to 9, So this is our stroke for the 2. And then we have 12, which is 10 to 19. So we will have our stroke. Then 20, 24 to, we'll have 20 to 29, and that will have our stroke there. 14 will occur at 10 to 19, and then 1 will occur at 0 to 9. Now, when we look at the tally that we made, you will see that the first interval, which is 0 to 9, has the frequency of 3. The second interval have frequency of 6. The next interval is 5. The next one is 4. And then the last interval, which is 40 to 49, is 2. Mind you, we also considered the class midpoint and then the class width. Now, the lesson that we are going to look for today, it will entail all these things that we did earlier. Without wasting my time, let's zoom into our topic for today. Let's look at some properties of histogram by considering the diagram. A histogram, we are saying that, is a graphical representation of a frequency distribution. And only when the data that we are dealing is quantitative, we cannot draw a histogram for it. So histograms are drawn for only quantitative data. Looking at the diagram, there are no gaps between the bars, rectangular bars. So we are saying that histogram has no gaps between the rectangular bars. If there are gaps between the rectangular bars, then it means that there are no frequencies for that particular class boundary. We can also see that the class size for each boundary is the same, making the width of the rectangle being the same. So in histogram, the class size should be constant, and the y-axis will be our frequency, and the x-axis will be our width. That is where we are going to represent, or we are going to present our class boundaries or our class width on. So that will be our x-axis. Now let's look at illustrative example 1. Here are the grades of 15 students. So the data is given below. Using the interval of 10, draw a histogram for the data. So our solution, we draw our table, and we have on the table, that is the score, tally, and then the frequency. Since the interval is 10, 10, 10, we consider the least value, and the least value here is 48. So we will start from 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, and then 90 to 100. Let's start our tally by taking the first value, which is 85, and 85 will be at a class boundary of 80 to 90. So we make our tally. 48 will be at the class boundary of 40 to 50, we make our tally. 60 will be at 60 to 70, we make our tally. 51 will be at 50 to 60, we make our tally. 57 will occur at the boundary 50 to 60, so we make that one too. The next value, which is 85, will be found at the class boundary of 80 to 90, so we make our tally there. 69 will be at 60 to 70, we make our tally. 75 will be at 70 to 80, we make our tally. 97 will be at 90 to 100, so you make your tally just like that. So it follows like that. The value determines where you make the tally. After making the tally, you count the number of tally made. So with a class boundary of 40 to 50, we have one tally, so the frequency for that class is 1. 50 to 60, we have 2, so the frequency is 2. 60 to 70, we have 4, and it's 4 for the frequency. 70 to 80, we have 5 tallies, so the equivalent frequency is 5. 80 to 90, we have 2, so we have the frequency to be 2. And then 90 to 100, we have the frequency to be 1. Now let's represent this data graphically. So we draw our axis, that is the x and then the y axis. We scale it with equal interval, and then we know that the x-axis will be our score, and our score starts from 40 to 50, and then we have 50 to 60, so we represent it by 40. The next one will be 50, 60, 70, 80, 90, 100. We do the same thing to the frequency, which is 1, 2, 3, 4, 5, and then 6, because the highest frequency is 5, so we end it there. Now our x-axis represent the score, so we write the score there, and then the frequency represent the number of students. Considering the first class boundary, which is 40 to 50, it has a frequency of 1, so the height of the bar should be 1, so we draw our height to be 1 on the boundary 40 to 50. The next boundary, which is 50 to 60, has a frequency of 2, and that one too will have the height of that bar will be 2, so we draw the height to be equivalent to 2. The next boundary, which is 60 to 50, has a frequency of 4, so the height should be 4, so we draw our bar to have that equivalent height, which is 4. Moving on to the next boundary, which is 70 to 80, with a frequency of 5, we have the height of the bar being 5, and we draw it nicely like this. Then the next boundary, which is 80 to 90, with a frequency of 2, the bar will assume a height of 2, so we draw our bar to be the height of 2. And then the last boundary, which is 90 to 100, has a frequency of 1. So the height of that bar will also be 1. Now, since this data or this graph represents the class grades, we give it a topic, class grades. So this is how we represent a data graphically, which we use histogram. Let's look at another illustrative example. Example 2. The weights of 30 students in a class are as follows. So this is the data, and the question is saying that we should choose a class interval of 5, prepare a frequency distribution, and draw a histogram. 2. Estimate the mode from the histogram. Now let's organize our data into frequency distribution. But the data given to us is this. So let's draw our table for the frequency distribution. So we will have the weight, which is in kilograms, the tally, and then the frequency. The class intervals was 5. So we start from the minimum value in the data, which is 40, and then we end with the largest number, which is 62. So we start our tally by considering the values one after the other. The first value is 42, and it will be at a class boundary of 40 to 45. So we have our tally there. The next one is 52, and that will be at a 50 to 55 class boundary. 46 will be at a 45 to 50 class boundary, so we made a tally. 63 will go into 60 and then 65. 47, we have 45 to 50. 40, we have 40 to 50, 45. 50, we will make our tally at 50 to 55. And then 63, we have the tally to be made at 60 to 65. 52 will be at 50 to 55. 57 will be at 55 to 60. 40 will go to 40 to 45. And then we do the rest as we know it already. So after that, we count the number of tally for each boundary, and we know that the first one is 5, the second one is 6, the third one is 8, and then the next boundary is 6, and then the last one is 5. So in all, when we total the number of frequencies that we have, it should be equal to the number of students given, and that is 30. Now let's represent this graphically. And when we are drawing a histogram, we take our y-axis and then our x-axis, we scale it to get equal intervals, and then the x-axis being the weight, which was given in kilogram, we represent the class boundary on the horizontal axis, which is the x-axis. So we have 40, 50, 45, 50, 55, 60, 65. The same applies to the frequency, which will be on the vertical axis or the y-axis. And that one too, we have 1, 2, 3, 4, 5, 6, 7, and then 8, because as usual the largest value at the frequency is 8. Now let's consider the y-axis. That will be our weight in kg, and then our frequency, which is the number of students. Taking the first class boundary, which is 40 to 45, we have the frequency of 5. So the height of that bar will be 5. So we draw that bar to assume the height of 5. Considering the next boundary, which is 45 to 50, that is 6. So the height of the bar should be 6. So we draw it like this. Bearing in mind that in histogram there are no gaps. The next will be 50 to 55, and the frequency is 8. So the height will be 8, and then we draw our bar like that. 55 to 60, the class boundary, we have the frequency to be 6. So the height should be 6, and then we draw our height on that boundary. And then the last one, which is 60 to 65, we have the frequency to be 5, and then we draw our bar on it. So we are saying that this is a graphical representation of the weight of students that we have. Now our second question is demanding of the mode. In estimating the mode from the frequency or from the histogram drawn, we draw a diagonal from this edge to that of this edge as shown, and then we draw a diagonal from this edge to the next edge at this place like this. So where they intersect, where these two lines intersect, we draw a vertical line to the x-axis as this. So we trace the value that we will have at the x-axis, and that value will give us 52.5. Therefore our mode from this distribution or from this histogram is 52.5. Now today we have learned about how to draw a histogram for a given data. We saw that for histogram there are no gaps in between the bars, as we saw it for bar graph. And for histogram too, the frequency is always at the y-axis, and then the score or the width will be on the x-axis. Now let's take this trial test. These are the trial questions. 1. The distribution of the marks scored by 30 girls in an examination is given by as follows. Using the class interval 1 to 10, 11 to 20, 21 to 30. 1. Form the frequency distribution. 2. Draw a histogram to represent the distribution. 3. Using the histogram, estimate the mode. Second question. The table below gives the distribution of the scores 80 students. Draw a histogram to represent the distribution, and using your histogram, estimate the mode. This is where we will draw our curtains to today's lesson. But mind you, we are going to treat cumulative frequency in our next lesson. So dear learners, do prepare and see you same time next week. Bye bye.
We sing to you, Lord. Oh, we lift our voices and sing. We worship you. We sing to you, Lord. We sing, we sing, we sing, we sing, we sing. Oh, we worship you, Lord. Oh, thank you, Lord. I will sing. Oh, yes, I will. I will sing.